Good morning. We're going to look at a little bit of the Pythagorean theorem with paper folding. I'm going to start with a square. Doesn't matter what size square. They're all the same. I'm going to fold it in half. In this case, I'm folding it down the middle line of symmetry so I can get the center of this side. Now, next thing I'm going to take this corner and fold this corner up to touch the middle of the center. Right there. You will notice when I do this, I get a right triangle over here in the corner. I get another right triangle on this side over here. I don't need to draw these lines, but I am for emphasis. These two right triangles would be similar. In fact, I could argue that I could say this one down here is also similar because all three have the same angles. We could show that quickly if we want to. If this angle is x and this angle is y, x plus y must equal 90. This is the right triangle. This one over here, if this is x and we call this a, x plus a must equal 90, so that y must be equal to a. So if this, and then this one up here will be x. So they're similar triangles. What more interesting, I'm wondering about what are the lengths of the sides on this triangle? Well, let's pretend this sheet of paper is 8 by 8. So that means this is 4. This number we don't know, so we'll call it x. But we do know the hypotenuse. Is if I unfold this, the hypotenuse is this length right here. So I fold this up here. This is going to be 8 minus x. And again, we're looking at some key areas of Algebra 1 right here right now. Okay, I've done this, and I want to solve for x. Well, how can I do that? I'm going to use the Pythagorean theorem. 4 squared plus x squared equals 8 minus x squared. Square everything. 16 plus x squared. Don't forget to FOIL it properly. 64 minus 16x. I'm not a fan of FOIL, but that's okay. Got this. I now need to solve for x. Notice the x squareds cancel. So if once I solve for x, it's got to be a rational number, which is an important thing to notice. Okay, I'm going to do some math over here. Got to move the 16x over here. Just make it positive. Subtract that over here. I think I get 48. Is that right? 50. Yep, that's right. Divided by x. Yep. Equals 48 divided by 16. X equals 3. What a coincidence. This is 3, so this is 5. So we have made a 3, 4, 5 right triangle, a Pythagorean triple. Now the point I wanted to make is with this folding, with this formula, since the x squareds cancel, I'm always going to make a Pythagorean triple when I fold to a corner like this. I'm now going to repeat this process with a different piece of paper. Again, we're going to pretend it's 8 by 8. It's not, unless well, here's a smaller sheet. We're going to do the same thing. I'm going to fold it in half. Then I'm going to unfold it, and I'm going to fold a quarter in. So now I have a 1/4 point right up here. I'm now going to fold this corner up to touch there. Now, a lot of this is going to be the same. Since I pretended this was 8, and I could have pretended it was anything, that was 4, this would be 2. Again, this is still x, and this is still going to be 8 minus x. I can now solve this. 2 squared plus x squared equals 8 minus x squared. 4 plus x squared equals 64 minus 16x plus x squared. We've done some of this already. So we get 16x equals 60. X equals 60 divided by 16. Divide both by 4. Get 15 over 4. 15/4. Now, to those of you that know your Pythagorean triples, you could probably figure out things from here, but I'm going to go ahead and do the math. I did this once on a video and messed it up, so I have 8 minus 15/4. 8 is 32/4 minus 15/4, or 17/4. So we now have 17/4, 15/4, and 2. If we multiply all those by 4, so we get rid of the fractions, we have 8, 15, and 17, another well-known Pythagorean triple. And I can do this with any fraction at all. Hope you enjoyed that.